It's UofL Today on 93.9 The Ville. Here's your host, Mark Hebert.
And welcome to UofL Today with Mark Hebert on 93.9 The Ville. So glad you're joining us. This is the show about all things UofL. We talk about research, we talk about great students, programming at the University of Louisville. So we've got a great show over the next 30 minutes. Hope you'll learn something by the end of this program. So coming up a little bit later on today's program, you'll meet one of the top graduates from UofL, Rosalind Steinmetz. She had previously won a prestigious Fulbright Scholarship. Now she's won another big international scholarship. And the ways that engineering and medicine collide and produce beautiful technology. We'll have a professor talking about that. But first guest are two guys who work in totally different departments at UofL, but they're doing research together on stopping a disease that affects the mouths of 1 in 2 Americans. Don DeMuth is Associate Dean for Research in the School of Dentistry. Fred Luzio is a chemistry professor in the College of Arts and Sciences. Welcome, gentlemen.
Thank you.
Glad you're here. Mm-hmm. All right, well, let's talk a little bit about periodontal disease. Did I say that correctly, first of all?
That's correct,
All
yes.
right. Well, what is PD?
It's really a chronic inflammatory disease that occurs in the mouth. It is a bacterial-mediated disease, so there are bacteria that initiate the disease, and our bodies respond to that infection by stimulating an inflammation response, which becomes uncontrolled and leads to tissue damage, ultimately bone loss and loss of the teeth.
All right, that was Don, by the way, so you can distinguish the voices here. All right, well, Fred, what role are you playing in this research that the two of you are doing on periodontal disease?
Well, I'm a synthetic organic chemist, and basically I make compounds which Don evaluates as a therapy against the PD disease. So I'm a synthetic organic chemist, and the compounds that I make are actually not only used in this project, but also in other projects like cancer and neurosciences.
Well, we'll talk a little bit more about the specifics of the research you guys are doing here in just a second. What is periodontal disease, and why is it such a big deal? Why are you two interested in this?
Well, you already alluded to one important aspect, and that is it's very widespread. And you said almost 50% of the adults in the U.S. There are populations where incidence is even higher. If you are a smoker, it's maybe 70% of the smoking population can show symptoms. In developing countries across the world, incidence is much higher. So it's probably one of the most common bacterial infections in humans. And it's been associated with other systemic conditions. So it's an inflammatory disease. It increases inflammatory markers across the whole body. And that presents an increased risk for heart disease, for rheumatoid arthritis, and even for some neurologic disorders.
So what's happening in your mouth could affect what's happening in your heart? Is that what you're trying to tell me?
Definitely.
Okay. And that's what we get to your research, right? That's what you're trying
correct.
to figure out how to stop this. So why don't you start, Don, tell us a little bit about specifically what your research is about, and then we'll get into what Fred's working on.
Okay, well, in general, our approach is if we can prevent periodontal disease from occurring, then we can reduce the incidence of these systemic illnesses that are associated with the disease. So many years ago, we started studying how some of the bacteria that are associated with periodontal disease colonize the mouth. Mm-hmm. And as a result of that, and understanding in particular how one organism, which we just call PG, or Porphyromonas gingivalis.
Yeah, sure.
PG.
Sure it is.
So we started studying how that organism joined the community of bacteria that exists in our oral cavities. And from those studies, we developed a peptide that prevented PG from colonizing the oral cavity and showed that it prevented periodontal disease in an animal model. So we're trying to develop that as a potential therapy for use in humans.
Okay. Well, Fred, what's a peptide? What is that? What?
Well, a peptide is a biomolecule. Peptides are biomolecules which are found everywhere in living systems. So peptides compose proteins, tissues. Peptides also compose hormones, and so and they have many roles in living systems. So it just so happens that the peptide that we're studying can inhibit this type of malady.
Right, and the bacteria from forming. Is that what it
That's correct.
technically does?
Right.
And the bacteria actually adheres to the oral tissues through the use of a protein. And this peptide was derived from that protein and actually competes with the organism for that interaction to occur. So it blocks it from colonizing.
So if you come up with this peptide that works like this, is this something that you and I and everybody else should be doing as we brush our teeth every night, that we got to figure out a way to get this peptide in our toothpaste, or is that what you're working on, or I don't know how?
It's gravitating towards that. Actually, what I am working on in my laboratory is not the actual peptide, but a smaller compound which is less expensive to make, and it will last longer, and it's even more inhibitory than the peptide.
But it's similar. It has the similar characteristics
right,
as a peptide that would block
absolutely.
periodontal
It's called a peptidomimetic. So it's a small molecule which can mimic the peptide, but it's easier to make, less expensive, it's more compact, and it's the type of compound that drug companies look for to make in all types of therapies, not only a therapy like this, but other types of therapies as well.
That was Fred Luzio, who is a chemistry professor at UofL, and we're also talking with Don DeMuth, who's Associate Dean for Research in the School of Dentistry, and we're talking about their research on periodontal disease and how to stop it. You talked this was a cheaper way, potentially, to stop these bacteria from forming. How far along are you in getting this potentially to market or getting it approved by whoever, FDA or whoever has to approve it?
We are progressing along the commercialization pathway. Both the technologies, the peptide and the small molecules, are protected by issued patents. We are working with the Office of Technology Transfer to market it to various oral health care companies and have had some interest in that. The specifics that we need to accomplish are to do some toxicity testings to ensure that our peptide or our compounds are not harmful to human.
Okay.
And so we're working with that and trying to improve efficacy of some of the active agents.
Have you started a study yet? Are you down the road far enough? You said you got to test and see how it works in humans, but
yes.
have you got to the point yet where you've?
We've not done human studies
okay.
yet, and to get to that point, we'd probably have to do these toxicity tests first. We've done some with the peptide, and it's a very stable compound and is non-toxic to everything that we've tested so far. We haven't done a lot of toxicity testing with the small molecules that Fred is making, but just this week I had a person in the laboratory start those studies, and the results so far look promising.
Very good. All right. Well, what would you tell folks? What's the best way to avoid periodontal disease, Mr. Dentist Don DeMuth?
Good oral health care.
Brush your teeth all the time.
Brush your teeth, visit the dentist regularly, and when our product gets on the market, use it.
And how long might that be, realistically, before something like this gets on the market?
Well, we've applied for a commercialization grant through the Excite program in the Cancer Center, and we haven't heard the final outcome of that yet, but the indications are very positive, and that would be a 2-year grant that is directly intended to get us to the point where we can start human studies and start to commercialize.
By the time you get that, and then the clinical trials, and then approval from
Yes.
the feds, and all that, you're probably talking 6-7 years down the road, maybe?
I would.
I'm
By
just
time
guessing.
FDA approvals, yes, and doing the clinical trials that would be required, yes, that's probably a reasonable estimate.
Okay. Before we go, Fred, anything else you're working on that's interesting in the chemistry field that we might find entertaining or useful down the road?
Absolutely. In my laboratory, we also work on analogs of thalidomide, which is a very important compound that's used in cancer and other types of treatments. So we're looking at the ways we can modify thalidomide molecules, which is historically a very famous molecule in human drug development. And also we're working on neurotoxins that are derived from a common plant called the pawpaw.
The pawpaw?
That's right, which
Like
is a
the things
natural
you eat?
product. Right.
Okay.
Exactly. And some of our earlier work has indicated that the pawpaw, even though people eat it, it's neurotoxic. So we're trying to, and it's also has some anti-cancer properties. So we're looking at lessening the neurotoxicity of pawpaw and maybe increasing the anti-cancer properties of this type of natural product.
All right, very good. Interesting work going on at the University of Louisville, isn't there? And we're glad you guys in 2 different departments are working together to try and come up with some solutions to periodontal disease.
All right.
Appreciate it. All right, Don DeMuth, Fred Luzio, thanks for being on. Appreciate it. Rosalind Steinmetz is a 2013 UofL graduate who's about to head to England to complete a master's degree, and she's getting it paid for through the scholarship she won from the College of Arts and Sciences. A couple of years ago, Rosalind won a prestigious Fulbright Scholarship, and as I just said, she's won another one, so it just keeps piling up the awards. Welcome, Rosalind.
Thank you.
So tell us, what is this most recent award you have won and what you're going to be doing?
This is the Mary Churchill Humphrey Scholarship Award, and it was started in the late 1940s, and it's for a graduate of the College of Arts and Sciences at UofL to spend a year of study in England. So I'm going to be getting a Master of Science in Gender Research at the London School of Economics and Political Science.
And the Master's in Gender Research, and what was it? And
at LSE, the London School of Economics.
Gotcha. Why did you pick that? Why did is this a thing where you can decide where you want to go with the award, or is that the school that this award goes to?
This award is good for any graduate of the College of Arts and Sciences to study at any school in the United Kingdom. And I chose LSE because they have a really great program in gender research. I did my research in Paraguay on women in politics in that country, and I have a background in Spanish and political science, and so this is a really good opportunity for me to get some formal education in gender theory and how to apply that while conducting social science research.
So what do you want to do when you get back? What are you going to do with your life?
I'd like to go on to get a doctorate in political science and continue researching women in politics.
Okay. And you, as we said, you graduated in 2013. So what are you doing right now before you get ready to go over to England?
Right now I'm working and mainly working at La Casita Center, a nonprofit organization in town that works with Hispanic and Latino population of Louisville.
I was looking at your background. You are just a world traveler, aren't you?
Yeah, yes, I am.
Your time at UofL, you've been everywhere. So why don't you tell folks where you've been and what you were doing in those various and sundry countries that you visited?
Okay. First, I went to Panama, and I went to Panama with the Brown Fellows program before my freshman year, but I returned right after my freshman year with the study abroad program at UofL, and completed a few credits there and an internship with the Impacto project teaching photography. And then returned to UofL for my sophomore year, and through the course of the second semester then, I was working with the International Service Learning Program. And so we went to Trinidad and Tobago and taught some about a week-long course there. And for my...
And to Panama too, right?
Yes.
Okay.
And during my junior year, I was in Buenos Aires, Argentina, with the support of several scholarships from the University of Louisville. And I was studying political science at a private university there.
Wow. So you've had quite an experience at UofL, haven't you?
Yes, I have. It's been wonderful.
And I know you're going to be modest about this, but Rosalind was one of the first Brown Scholars at the University of Louisville, in the first class of the Brown Scholars, which is the top scholarship at the University of Louisville. All expenses paid, you get the trip and all that kind of stuff. And you were also a Fulbright Scholar. Why don't you tell folks what a Fulbright is and what you did on your Fulbright?
Fulbright is a scholarship for research or to teach English, and I got a U.S. student Fulbright research grant. So that was a stipend to pay for me to study in Paraguay. So I lived in Paraguay for all of 2014 and was able to conduct some secondary and primary research on women in politics in that nation.
All right, once again, we're talking to Rosalind Steinmetz, who has just won another scholarship as a graduate of the University of Louisville, but as you just heard, has been several places around the world on some other scholarships as well. What do you think was the one thing at the University of Louisville that got you in position? Obviously, your brains and your culture and all those kinds of things got you in the position you personally were in, but there were some other things that you had to have at the University of Louisville that got you where you are today. So what were those things?
The top things would be the professors. I had a lot of really great mentoring relationships with professors, both in the Spanish and LALS departments and in political science, and they really helped prepare me both academically and with the essays as part of the applications for some of these scholarships. And the other one would have to be the Office of International and Prestigious Scholarships with Dr. Khan, and she helped me a lot. I applied for several scholarships through that office while I was at UofL, and ended up getting the Fulbright because of that.
And we should brag a little bit on this year's class. I suppose that Dr. Condon has ushered through that we have 14 Fulbrights this year, which ties the record that U of L had 2 other years, and is going to be one of the top, make U of L one of the top Fulbright producing public universities in the country. So that's kind of cool.
Very exciting.
So what can those students expect as they go on their Fulbrights? What should they expect when they go overseas?
Wow, a lot.
Well, what hit you when you got to Paraguay? You win the Fulbright. You go to Paraguay, and what did you find?
The most interesting thing for me about the Fulbright experience in research was the independence, that I really was doing everything on my own. And, they have contacts at the embassy, or if it's at a country where they have a Fulbright commission who will help you and help you make connections. But after that, it's all self-directed, which is really exciting and a great opportunity, especially for someone like me who wants to go on to continue doing research academically and professionally.
Now, you speak very fluent Spanish, I'm assuming, right?
Yes.
But you're getting ready through the Mary Churchill Humphrey Memorial Scholarship to go to England, where you're going to be able to speak English. So is that exciting to you, or do you wish that you were going someplace else that you could speak a different language and learn a 3rd or 4th or 5th language?
Well, I can still do that at the London School of Economics. They have a really great program for language learning and a lot of international students and some great student union clubs that I hope to participate in. But I'm really excited to be going to LSE because it's such a great school and has really great opportunities for education.
And I saw a poll the other day. I'm trying to remember where I saw it. It might have been in Time, that women are trusted more, but if they trusted more by voters, but if they are perceived one time as being untrustworthy, that they lose it. They can't. It's tougher to get that trust back, whereas male candidates can make a bunch of mistakes, lose the trust, and regain it. And I thought that was an interesting poll that showed what you just said, I think.
That is very interesting, and you can see that in Latin American politics a lot as well, that women are often voted in to leadership positions because they're seen as above the corruption of politics. So anytime that they're seen as making a mistake and falling into that, they're no longer valued as politicians.
So once you get back from London, though, I asked you what you were going to do with it, and you wanted to keep studying or get some sort of employment in studying women in politics. So are you wanting to teach at the college level, or what do you... or do research at the college level, or what are you thinking? I
would love to do research and teach at the university level. I know that that's a pretty competitive field right now, so I'd also be really thrilled with any opportunity to work with the think tank or with the United Nations. The United Nations does a lot of the scholarly research on women's involvement in politics and representation, particularly in Latin America. So that would be a really great place to work.
Oh, very good. All right, Rosalind Steinmetz, who's just won the Mary Churchill Humphrey Memorial Scholarship from Arts and Sciences, and as we've talked about, has won a slew of other awards from the University of Louisville. We're very proud of this 2013 graduate of U of L. Congratulations.
Oh, thank you. I'm very proud to be a graduate of the University of Louisville.
With me now is Amir Amini. He's a professor of electrical and computer engineering in U of L Speed School of Engineering, and he's doing research on biomedical imaging. Sounds like a lot of big words. Dr. Amini, what does that mean?
Sure. Well, biomedical imaging has truly revolutionized the field of medicine, Mark. And, it's been stated to be one of the top 50 inventions of the 20th century by the National Academy of Sciences. Of course, it basically, what it involves is basically interaction of some sort of an electromagnetic wave, electromagnetic energy with the body. So, for example, you might have heard of CT scanners. Most of your listeners obviously
know what a
have.
CAT scan is, right?
CAT scan, exactly.
Yeah.
So basically, that involves interaction of X-rays, which is a form of electromagnetic energy at very small wavelengths, with the body, and creation of, depicting what's inside the body, the anatomy, without, invasive means. So that's why it's so important. And, CT is one example. Of course, we have MRI, we have ultrasound, we have nuclear medicine, and now more later techniques are optical imaging. So all of these methods give physicians the means to look inside the body non-invasively, without using for example, a scalpel to open up and see what's inside.
Well, we'll talk a little bit more about MRI and CAT scans and what's the difference here in a minute. But I should ask, you are in the Speed School of Engineering, so you're an engineer, but you also work with the School of Medicine. So how does that work?
Sure, absolutely. So I work very closely with cardiologists, with radiologists, with lately we've talked with some surgeons to start collaborative work. We can't do our work in a vacuum. You know, we have to have human subjects. Earlier when I was in St. Louis at Washington University, I work with animals. So basically we need to test our methods. We need to develop our methods in conjunction with physicians. So it's a very close collaboration, and I have courtesy appointments, even though I'm at Speed School. In a prior life, when I was in St. Louis, I did have appointments. Actually, my primary appointment was in the medical school. Okay, but here I'm in the engineering school. I'm interested in teaching and educating as well. So, I wear different hats, in terms of both teaching and, research. With research, I certainly work very closely with my physician colleagues.
So is your research focused on just trying to find new and better ways to do imaging of the body? Is that, in a nutshell, what you're working on?
Exactly. The field of medical imaging, in the technical sense of the word, basically involves how to acquire the images, how to better acquire images from the human body, and how, lately, because of the humongous amount of data that's created, how we can develop computerized methods to help physicians in determining where, for example, a malignant nodule might be, or where a disease process might be automatically. That's the field of computer-aided diagnosis. So my field of research basically spans, the whole gamut from how to acquire images, the sort of physics and engineering of the techniques, what's under the hood, so to speak, all the way to, when you collect the data, how do you process the data using, powerful computers to help physicians in determining where the disease process is.
We're talking with Amir Amini, who's a professor of electrical and computer engineering at UofL Speed School, and he's doing research on biomedical imaging. What's the difference between a CAT scan and an MRI?
Sure. There are some similarities and some differences. The similarities are that both in the case of a CAT scan and an MRI, the physicians are able to see, to basically make a diagnosis of the disease using three-dimensional images, so-called tomographic or tomograms, tomographic images of the body, cross-sectional images that non-invasively are acquired that depict what's inside the human body. So that's where the similarities. The differences are that the actual electromagnetic radiation that gives rise to the images are certainly distinct and different. In the case of a CAT scan, use X-ray. So there's an X-ray tube and there's a set of detectors, as you might have been inside an X-ray CT scanner. So it basically, in the gantry, the
circular thing goes
rotates
around
very quickly. So what it's doing is basically at each, in a split second, literally, in microseconds, you have X-rays that are shooting through the body, and you get attenuation map on the other side, and these attenuation maps are put together to reconstruct a 3D image. So that's in the case of X-rays. With respect to MRI, even though CT scanners are very important, they have ionizing radiation. So somebody that gets a lot of CT scans over the years, lots of radiation that can be harmful and hazardous to one's health. In the case of MRI, MRI doesn't have as good a resolution as CT, but it has very good soft tissue contrast. But what it involves is basically you're imaging the hydrogen nuclei in the body, the protons, using a method called a nuclear magnetic resonance. Okay, so basically it's radio frequency waves, which are in the FM range, actually, similar to how your radio show is being broadcast. It's the same kinds of frequency, which are non-ionizing. So so that's it's non-ionizing, so it doesn't matter how many times you get an MRI. There's no hazard with respect to health. Although the scan time is slower, the resolution of them, the resolution of the images are not as good as CT scans. So all the imaging methods are important, and each of them have basically brings something.
Points.
Exactly, each one brings something to the table, and that's why no imaging method is going to
it's just an MRI or it's just a CT scan. It's going to be up to your doctor to figure out
exactly.
Which one
Exactly. They're all useful. They're all useful, and
you.
they will continue to be useful.
You have a grant application in front of the National Institutes for Health. What is, in the simplest terms you can describe, what is that grant application for?
Sure. So basically what we're looking at is something to do with patients with cardiovascular disease. So there is a disease of the heart, called aortic stenosis. So when your heart pumps blood, basically it's the left ventricle that pumps oxygenated blood into the body through the aorta during the systolic phase of the cardiac cycle. So what happens is that very similar to how you might have how one might have an occlusion, a narrowing of a blood vessel. The same disease process could show up in the valve of the aorta, the so-called aortic valve, and
it's narrow and it doesn't allow enough blood through it.
Exactly. So it basically the valve doesn't open completely during systole. That's basically the valve. It's a tri-leaflet valve. It opens during when the heart ejects blood, so it doesn't open completely. So the heart is pumping against a resistance.
A wall. It's almost got a wall there.
Well, it's a hole with a very tight hole, which should be like completely open. So it doesn't open completely. So. So far, what's happening and how doctors use quite effectively a method called Doppler ultrasound, which also is non-ionizing, which uses non-ionizing radiation to image blood flow in the heart. So they use Doppler right now. So the idea that we had was basically me and my cardiology colleagues, Marcus Studdard, Glenn Hirsch, and Rita Coram, all doctors in the cardiovascular division at the University of Louisville, how to use MRI to improve the diagnosis, or perhaps see whether there might be situations where it would be advantageous to use MRI for the purpose of imaging the blood flow.
So you want to do a study of that, figure out if that's a better way to do things. All right, Dr. Amir Amini from the UofL Speed School of Engineering, thanks for coming on. We might have to have you back on when you get this study going on this new MRI process.
Sure, it's a pleasure. If there are any veterans out there in the audience who would be particularly interested in imaging them, so they can look me up on the web, and if they're interested in getting their hearts imaged, by all means send me an email, and we'll be more than happy to have see whether you can participate in the study.
Very good. That's Amir Amini at the University of Louisville. All right, as we often do on these programs, we wrap them up with a Did You Know segment, a little tidbit about the University of Louisville. So with the recent death of Muhammad Ali, here's your Did You Know segment for today. Did you know that Muhammad Ali had ties to UofL and inspired academic and research programming at the University of Louisville? Well, in 2005, the Muhammad Ali Institute for Peace and Justice at UofL started the Ali Scholars Program, a 2-year experience for undergraduate students that combines training, research, and service in the areas of violence prevention, social justice, and peacemaking in the urban living context. That's our show for today. So thanks for joining us for UofL Today with Mark Hebert on 93.9 The Ville, and go Cards.